Okay, while we are waiting, please show me that you are in good shape, right? Open the camera. Start the lesson right away. External camera. Let me know you are here, and we will start the lesson. Thank you. Now, refer to the book on the experimental method, right? We would have 2 more to go. Now, I'll repeat, please open the camera. And get yourself prepared for the lesson. And for the time being, I quickly check your attendance first of all. Chen Baojun, where are you? I cannot hear. I cannot see your name. Anyone who sees Chen Baojun? Now, once again, a reminder to change your name on your in the Zoom, such that with the class and class number, so that I can keep track of it more easily. Thank you. And Zhang Heijie, are you here? Zhong Longhian, no. Liu Hianzhong, oh yeah, I can see. Yu Hongzhong. Anyone who see Yu Hongzhong? And all right, we have got how about Zhang Hei? Anyone who see Zhang Heijie? No. Absent, right? Okay, I mark it absent. Now, my first question, we call your memory. We get to know the different types of experimental method to keep track, to monitor the progress of the reaction. Could you please, I will try to record the memory of each other. Tell me some examples. Any examples? Clement Chan, any examples of experimental method to keep track of the reactions? Any method? Clement Chan?
I forgot.
Forgot. Now, could you please take a look on the book, chapter 36, where we have got various methods mentioned. Trần Ying Zhen.
Measure the change in mass of solution mixed by weighting.
Yes, measure the change in mass of the solution mixture. How? By weighing or by weighing difference, right? What instruments will we use to weigh the solution mixture?
Electronic balance.
Yep, good. Electronic balance. Yes, that's right. So it is only for the reaction involving gases formation, right? So you use this. What else? One more method. Yes, Hugo.
Wait.
Besides weighing, what other methods would you suggest? Now, no need to take care of the reaction nature. Just give me different types of method mentions. Now, first student, tell me you are doing to weigh difference in mass of the reaction mixture using electronic balance. How about you? Now, besides, for example, we have got some gas formation, right? How will you know the amount of gas formed? How will you measure? Hi, you go. How? How?
I don't get what
How? For example, if you are going to measure the rate of the formation rate of a reaction between, for example, calcium carbonate and acid, right? You know, carbon dioxide will be evolved. How would you keep track of the reaction? Just like this, for example, if I want to make such curve happen, what instrument is needed to help you measure? For example, measure volume of CO2. How? What apparatus is needed? You use what? Do you have a book with you? Do you have a book?
iPad.
You may locate the page, or on 1110 you may get the page. I'll give you another chance, right, to think of third method.
Yes.
Yeah, what instrument is needed? How can we be done, right? I measure the change in volume of CO2 versus time. What apparatus is needed, or instrument is needed? So what is the design of experiment? What is the design of the experiment? Now, I give you one minute, okay? Let me know the following method mentioned last time. Okay, 2 minutes. Tell me what can it be done. I will come back later because I need to handle some DSE invigilation stuff. Wait for me. Oh. 係
你知唔知咧？我哋114考生係邊位人士啊？我覺得 trace 晒佢咧頭先咧，我講嘅佢頭先有
我叫佢諗住嘅先。Sorry, because I need to just handle some of the urgent stuff. Yes, that's right. That's right. Okay, so I just see somebody would you just write down, yes, measuring instrument just like gas syringe. Yes, that's right. So this is a gas syringe. So it is used to measure the volume of gas. Besides, we have got some other examples, right? So you may get to know this, okay? But for these two methods, it is only applicable for the reaction involving formation of gas, okay? But for example, if you want to measure the rates of neutralization, for example, so you can never use these two methods. Neither method can be done. Can you get my point? But the question comes, Mr. Chin, how can I know the rate of the neutralization reaction? How? It is too fast, right? You know that maybe mixing with the reaction just start at nearly end at the same time. Can you get my point? Because you have got two solutions. So whenever I have hydrogen ion, it collide. That means heat, right? They may heat on the hydroxide ion. We call it collide, right? So and to form water, and that's it. So not all chemical reactions can be studied by you. First of all, can you get my point? Because it depends on speed. You if you find the reaction, it may take you years to come. Of course, at our lab setting, you can also do this. For example, Form 1, you do it and wait for 6 years until you graduate and check the result. Of course, you can, but with a limited amount of time, or most of the time when you talk about DS exam, usually we would have the reaction that will be completed in minutes, for example. Okay, 1 or 2 minutes would it come to completion? Just go. Can you get my point? And depending on the physical properties that it can be measured, I use our own method. What do I mean by that? For example, you would have a gas formation, right? If you have gas formation, if I fixed the volume, of the container, what will happen in case that two chemical mix? So pressure will build up, right? Why will the pressure build up? Because of the formation of CO2, of hydrogen gas. Okay, hydrogen gas form, so pressure will build up. So in that is the case, if I fixed the volume of container, the pressure will increase. Okay, when reaction proceeds. So we would measure its pressure instead. Do you understand? So this is the way we come approach the problem. But of course, if you are dealing with the reactions without formation of gas, this is meaningless to them, right? Can you get my point? Because I cannot know the change in pressure. There is no change in pressure, so it's meaningless to do so. And what else is about if there is a color change, for example. Now you may find the change in color is from dark brown to a pale brown and finally colorless, right? For example, like this. So you cannot use the 3 of the method mentioned, right? So that's why I change. I will have some instruments to help you monitor the progress of reaction. That's why I use colorimeter. Okay, so we see the word colorimeter, the instrument which help measure the color intensity. Okay, but how will you know that is the dark color or that pale, right? So it will be too subjective to say how dark or how pale, right? Because different human will have different judgment. So that's why we will use some measurement. We will measure the absorbance instead. Absorbance, which means how much light is absorbed by the sample. How much light is absorbed by the sample. In case the sample is colored, they would absorb the light in which it is complementary color. For example, if the solution is orange, I will just choose blue filter. If the solution is blue, I will shine through orange light. Can you get my point? So why? Because that solution, why is it appear that color? Is because the white light will shine through that, they will absorb all other colors except that color. Okay. So we will use this complementary color. While this complementary color will be absorbed most by the colored solution. Absorb most. Okay, just choose the color of the complementary color. You will know it in chapter topic 15 again. So the general rule of thumb is that the absorbance, they will correspond to the concentration of it, is direct proportion. The higher the concentration of the solution, of the color solution, you know that it's darker color, right? So that means the more light will be absorbed. Okay, remember we talk about certain color light only. Okay, so that's why the color filter, the purpose of color filter is to choose that light. Okay, is that clear? Do you understand?
我想問下係咪個sample solution 咩顏色就用咩顏色 filter？ 聽唔明。
Complementary color. So why is it? Now, first of all, why the solution is blue? Now, for example, if in case we have got blue solution, I shine through white light. Okay, to you here, I see the solution is blue. Why? It's because it absorbs all other color except blue. Of course, the case is more complicated, right? So that's why we usually tell white light being 3 colors: red 1, green one, and also blue one. Okay, we will simplify the case by having red light, green light, and blue light mixed together is white light, right? So this is our understanding. So once I pass through the blue color solution and I look through here, so why is it appear blue? It's because they absorb what? It absorbed, here you see that red and green light seems to not to be found here, right? Know this, they will have know this. Why? Because these two color has been absorbed by the solution. So what is the mixing of red light and green light? It is yellow light. So that's why I would choose the yellow light filter. Why? Because in case I would show the another case, it is yellow filter. Yellow filter is a mixing of two light, right? In that is the case, if it is blue solution, what will happen? You may find that most of the solution will be absorbed. So nearly, you may say that nearly no light, right? Okay, nearly no light. So it appears dark to them. Of course, you may find that, Mr. Chin, you may find quite strange to comprehend because the whole setup, this sample, it is put inside a box with no color actually, just a tiny places here, but no straight light, no sunlight, okay? We just rely on the light inside. So theoretically, if you have got red and green mixed together as yellow light, it will be totally absorbed by the blue solution. The darker, in case the blue solution is much darker, the more yellow light will be absorbed. Can you get my point? So what is meant by absorbance? Absorbance is to compare this light, we call the incidence light, how strong the light it is. And finally here, maybe some of you may argue, it is not really no light, no light, this is just less bright light, okay? So it is the absorbed light. So try to get to know the difference between them, okay? The difference. The more the difference, which is, we call that the more light we absorb. So it is reflected by a number, we call it absorbance. 吸光度. The larger the number, which means that the more light will be absorbed by the solution. Of course, you cannot choose blue light. Why? Why not? Because blue light will not be absorbed by blue solution. So that's why we will call that red and green mixed together, that light, we call that complementary color, 對比色, which is just the opposite of that color. The color that will be totally absorbed by that blue solution. So we call it complementary color. Okay, do you understand? So, and if the solution is paler, what will happen? Of course, not all red and green light will be absorbed. They will let some light go, right? If it is paler, much paler until it's colorless, what will happen? Even all red and green light, they will pass through the blues, the colorless solution, and then let them go without absorbing any light. So the absorbance will become smaller. So that's why you will have this data, right? They will become smaller. If it is approaching zero, which means that no light absorbed. What is the hidden message? That color filter, or including the solution, the solution would not absorb that light. In its absorbance being zero. But is absorbance nearly 1.0, which means that all light of that color has been absorbed by the solution. What is the hidden message? The color solution is of high concentration. And this, how about this? What is the hidden message? The solution, the colored solution is of low or even zero concentration. So that's why the light will not be absorbed. Do you understand? This is what I just stopped at it last time. Do you understand? So This is the graph. While you see a curve, right? At the very beginning, very steep slope. And then later on, the slope becomes smaller. And finally, in terms of magnitude, okay? In terms of magnitude, how big or how small it is, right? Irrespective of the sign, right? Because this one is negative sign, right? Don't bother the sign, okay? Just tell how big or how small. We call it magnitude. And later on, it becomes 0. So we will know that the reaction has gone to completion. Okay? So this is what I know it last time. Besides, you may use other method, depending on the nature of the reaction. In case you know there is a pH change, I use pH meter. Okay. In case there is color change, I would use some instrument to measure the change in color, right? In case there is some gas formation, I use instrument to monitor how much gas is produced. Can you get my point? It depends on the type of reaction. So that's why we have got so many. You need to choose the correct way to do that experiment, to monitor the progress of the reaction. So here comes two more methods, right? So this is that marks the start of the reaction of today's lesson. Wow, 用完一堂啊呢度。Do you have any questions about the previous lesson? Now, how about this? 36.8. Now, for example, if you have got that reaction, what will happen? Now, sodium thiosulfate, thio means sulfur, right? And together with dilute hydrochloric acid, they will react according to this reaction. So you may find that colorless solution, colorless solution, colorless, 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 right? But this part, it is water soluble. You know the exit ring, right? So if I keep track of the reaction using gas syringe is problematic because they will back dissolve into the solution. Now, together with example, just like CO2 is also like that. We cannot, it will be some error, right? If you really want to measure the change in volume of the gas produced over time. Now, no need to mention the measure the change in mass of the solution mixture because the gas back dissolve into the solution, which means they added the weight, added the mass of the solution mixture, right? But very strange point is here. So please underline here. So you have got some solid form, yellow solid. So what will happen to that reaction? Now, indeed, it will take some minutes to go. For example, 10 to 5 minutes, 1 to 5 minutes. It depends on the situation. So the solution will become more turbid or more cloudy over time. The more time we wait, the more cloudy it is until the reaction stops. If that is the case, what should we do? Now, we have to think of another method. Okay, we have to think of another method. So try to see the video. I will show you how we will keep track of the reaction. Let's see. So you may find the reaction between thiosulfate and hydrochloric acid, that experiment. So you may have got this one. Now, I would like to show you this one very similar to what you know in the book. Now, of course, the purpose of experiment is different. Try to understand.
My job is to make college easier because students have a lot on their own.
So this is the first of 2 videos in which we're going to be looking at how we can measure the rate of a chemical reaction. In this video, we're going to be looking at the reaction between sodium thiosulfate and hydrochloric acid. Now, when the 2 solutions react together, they produce an insoluble precipitate of sulfur. And as that's made, the solution will go from being clear and colourless to a kind of yellow, cloudy colour. We're going to time how long it takes for that cloudy yellow colour to get so thick that we can't observe a cross that I have drawn on a piece of paper with a pencil. Now that cross is going to go underneath the reaction vessel, and we're going to simply mix together 50 centimetres cubed of sodium thiosulfate with 10 of hydrochloric acid. We're going to vary the concentration of the sodium thiosulfate and see what effect that has on the time it takes for the precipitate to form and for the cross to disappear from view. And we'll be changing that concentration by diluting our sodium thiosulfate with some distilled water. But to start with, I'm going to go for the most concentrated sodium thiosulfate, which is 40 grams per decimetre cubed, as it comes out of the container here. And so I'm going to measure out 50 centimetres cubed of this into my measuring cylinder. So as before, getting down to eye level so I can see the level of the sodium thiosulfate. I fill up my measuring cylinder. Ooh, almost there. Little bit more until I've got exactly 50 centimetres cubed measured out, and I'm going to pour that into the beaker. I'm now going to measure out just 10 of the acid, so I'm using a slightly smaller measuring cylinder, and again getting down to eye level, holding the measuring cylinder firmly so it doesn't fall over, and measuring out exactly 10 centimetres cubed. You can use a dropping pipette to do that, but I don't. Now the reaction is going to start as soon as I mix the acid with my sodium thiosulfate. So I need to be ready with my timer to start as soon as I add it. Just a swirl or two to get them well mixed, and then I'm going to observe the cross through the solution by looking directly above. Now, after a few seconds, you start to see the precipitate forming and the solution turning this cloudy yellow colour. But I'm going to watch from above until the cross has totally disappeared. Now, and stop the timer. And so I've got a time for my first concentration of 27.44 seconds. So that was the most concentrated. And so now I can vary the concentration by mixing different proportions of the sodium thiosulfate with distilled water, but still keeping the total volume as 50 centimetres cubed. So I'm going to measure out 40 centimetres cubed this time, carefully and slowing down as I get near the 40 mark, a little bit more, and I'm there. I'm going to pour that into my flask. But to dilute it, I'm going to add 10 centimetres cubed of the water. So keeping the volume constant at 50, but now reducing the number of sodium thiosulfate particles in that total volume. So we need to think, how is this going to affect the rate of reaction? Well, a reaction occurs when particles collide. And that collision has got to have sufficient energy for the collision to be successful. By diluting the sodium thiosulfate, I've got the same volume but fewer particles. So a collision is less likely. And so within a minute or a second, we're going to have fewer collisions and therefore a lower frequency, and in theory, a smaller or lower rate of reaction. So to start it off, I'm going to add my 10 centimetres cubed of hydrochloric acid, being careful again to get the measurement accurate. Reset my clock and start again. Pour the acid in, start the clock, give it a little swirl. And I'm keeping everything else constant. I've got the same volume of solution, I've got the same cross, it's the same person observing it. I'm going to watch directly from above until I can no longer see that cross. So as you're looking down into the flask, take care not to breathe in the sulfur dioxide fumes that do come off, because it can make you cough. So the precipitate is appearing at a slower rate. The time is longer this time. And as I watch from above, the cross has disappeared. This time at 32 seconds. So the reaction time is longer, so the rate is smaller. So I would repeat this 5 values for.
Okay, do you understand? Okay, so indeed, she has tried to measure the rate of the reaction between that two chemicals, but this time the first time and the second time, the first set and second set experiment with the different time of completion of experiment, right? But it's not a completion, okay? That they will not go to completion. Now, why do I say so? If you check the color of the solution over there, can you see that? Now, this one, it is a timing where in the middle, take a look in the middle. So you may see the yellowish solution is paler than that of the yellowish solution just behind the timer. Can you see that? So what is the hidden message? The reaction still continue even though you think your own part has finished. I just place here and let them go. Okay, you get my point? We are not using this to keep track of the whole progress of reaction. And it seems like we design a special moment in which I would have an easily observable stage. Okay, so let me introduce to you something more about that reaction. Now, the whole reaction will be, the design will be like this, okay? We have got a conical flask containing the solution, sodium thiosulfate solution of the corresponding concentration. While I add dilute hydrochloric acid here, while at the moment, while I add this, I start the timer. Okay, I start the timer and keep track of the progress of the reaction. Now, how do I design the stage? Is to put a mark cross on the sheet of paper underneath the conical flask. I will look upon just vertically above the conical flask. While you look through that without anything else, of course, the mark cross can still be seen, right? After some time, because sulfur will be formed and they will try to blur your vision. The more the sulfur form, they will blur the mark cross. So you may find that the mark cross, while you look through the color solution, will become fainter and fainter. And try to wait for a moment until it is totally blocked. The first blockage, the totally blockage, determined by you, we try to stop the timer and measure the time. Can you get my point? So this is the moment in which the mark cross has been blotted out. Okay, the mark cross has been blotted out. Indeed, if you really want to compare this sense to our old experiment, you may have this range curve, isn't it? Please copy it down. The range curve will show you the mass of sulfur form over time like this, right? However, we do not have any instrument for you to measure the mass of sulfur form. Instead, I use indirect method. How? It depends on the mark cross here. The mark cross. By comparing the color contrast between black and white, okay, that type of judgment, it will be more easily seen. Instead of telling you how yellow the color is, right? How yellow is quite difficult to judge, right? But if you measure the time for the moment in which the white course, the black course should be totally covered by the sulfur, but it's more easily seen. I designed it like this way. Of course, you need not really make a cross. It depends on you. If you want to make it as an apple, orange, right? Whenever it is, it should be okay, as long as some color contrast between black and white. Even though a big dot is also okay. It's a it's your own design. Of course, it depends on different people. While you use the black colored to have a color contrast in black and white, but for somebody who use a blue pen to make a cross, of course, the timing is different, right? Can you get my point? T1 is different, depending on you, and also depending on the human judgment, even though you use the same cross. For example, Liang Parker, you measure at 30 seconds to judgment as the total blockage of the mark cross. But it's not the case when you compare with Byung Hao, because they each of us will have our own judgment. Can you get my point? So the T1 actually doesn't refer to the completion of the reaction. It just tell you certain amount of the sulfur which can really cover the mark cross. So we will use that term the mark cross to be blotted out. Can you get it? Please write it down. Mark cross to be blotted out. So the time T1, which will refer to the mark cross to be blotted out, while for the reaction still continues afterwards, it's none of our business. It's not what we want to mention. Can you get my point? It's quite different. It's quite different from the previous example. From the previous example, you need to wait until the end. Can you get my point? We just stop at a certain moment, and that's it. Can you get my point? It's just like running 25 laps, right? For the previous example, right? You need to wait until you really finish the 25 laps until I stop the time, right? But for this card, no. I just want to keep track. You still need to run 25 laps, but I just give the timing when you have gone through 5 laps, for example. Okay, I just stop the time. This is the mark cross seems like I designed 5 laps. Can you get my point? But indeed, you still need to run for the 6 to the 25 laps by yourself. But it's none of my business. I don't bother. So that T1 is carefully designed by put across. Can you get my point? Is it a continuous method? No, it's not a continuous method. I just have one data only. Can you get my point? I just have one data only. Oh, so Mr. Chin, if you have got just one data only, so what is the meaning behind? What's the meaning behind between one time? Now, of course, using one data alone doesn't help, but comparing different data really helps. Recall your memory about video. What did the lady do? What is the purpose of experiment? Do you know? What is the purpose of experiment? Lin Wenjun, do you know the purpose of experiment? What did the lady do?
She dilutes some
Nice. Dilute, yeah.
Compare the
Dilute
time compare the time that the mark to be blotted out.
So it is well justified, right? That's for the second set of experiment. It will take longer time, right? Why? I dilute what solution?
As the solution diluted, the particles inside decreases.
Oh,
so that
inside decreases. What physical quantities are you going to talk about? Decrease in number, you mean? Decrease in speed or decrease in what?
The number of particles decreases, and the chance of colliding.
Oh, good. I much appreciate, right, your the attentiveness, right? You talk about collision. Good collision. Now, indeed, for the reaction to proceed, we will talk about this concept, collision. Okay, the collision. Whenever you talk about the reaction, first of all, it must collide. So you will know this concept in the later chapter. But yes, that's right. You are going to change the factors that may affect the number of collision. Indeed, if you want to talk about it in a more precise, more concise way, we talk about effective collision. Now we will get back to this concept later. Okay, good. So the timing, you're going to compare the time, which is indirectly equal to the rate. So rate, you may see that item. Do you realize that, for example, in biology, right? You may heard of this, right? If you're going to compare how different factors affect the reaction rate, we usually see this item, isn't it? So we will say that the rate is inversely proportional to time. So what does it mean by time? Time is not a completion reaction. Time, it is what you design. For example, I designed a cross. So we will say that this is the time taken for the easily observable stage to occur. In this case, you are going to design it as a time taken for the mark crossed to be totally covered by the sulfur formed. Can you get my point? Or you use the word the macros rule to be blotted out. Okay, so because we have got that 2 data only, what I'm going to do is to make the time and 1 over it and try to use this data to measure. Of course, you know that the shorter the time taken, the faster is the reaction. So that is the relationship. By comparing the different concentration of sodium thiosulfate solution in the video, you may know that the time is different, which means the rate is different. So I will know how the concentration change of the sodium thiosulfate changes would affect the rate of the reaction quantitatively, but not merely tell me it changed, right? But I will tell you what is the extent of change. Can you get my point? So we call it quantitative. Do you understand? So by using this method, you may see you can only measure the time taken for the reaction which is turbid stage, but you cannot keep track of the whole progress of the reaction. Cannot, okay? You cannot. So this method is also useful or meaningful in terms of comparing how different factors affect in case it changes, right? How does it affect the rate of reaction? For example, I want to know how the concentration of thiosulfate changes the rate of reaction. So what should we do? I change the concentration of sodium thiosulfate only, which means what? How about the concentration exit? No change. How about the temperature? No change. Can you get my point? All those I just mentioned, it is just another factor that may affect the reaction. Of course, something about the design. For example, we call your memory. The flask here. How the size of the flask? I cannot have it one big and another second experiment we call a small big conical flask. You know it? We cannot. Why? Because if I change it to the small conical flask, once I mix the solution, the height of the solution will become higher. So that will blur your vision so more easily. Can you get my point? What does it mean by blur vision more easily? Is that even though it doesn't have that so-called certain amount of sulfur, that may be paler, right? Paler cloudiness would already enough for you to cover the macros. Do you understand? So even though I for the use of conical flask, I still stick back to the same size. Can you get my point? It's quite rare to talk about this, right? Now, why do I insist of having you get to know about this? It's because it is a measurement of light transmitters. You know that light transmittance is something related to absorbance, right? Isn't it? While the height of the solution would really another factor that may affect your results. So that's why conical flask must be of the same size. Fair test, right? Temperature should be the same, right? And you need to know concentration of thiosulfate or hydrogen ions. It depends on what is the factor you are going to study. If you are going to change this one should be the same. Or vice versa. Can you get my point? In case I want to study how this is the factor, all those others should be the same. If I am going to change how the temperature affects the reaction, this change same, and this part I need to force it to be the same. Can you get my point? I change it correspondingly. Fair test, okay? All of you, please mark it down. Fair test. The concept of fair test should be noted. Any questions so far? Easy, right? Understood? So you go to the final method. Oh, okay, Mr. Chin. In case there is no gas formation, in case there is no gas formation, that means no pressure change, no volume of gas change, no mass change. For the solution in which you don't have any color change, you don't have any cloudiness of the color of the solution, What can I do next? Any other method? Sadly, we need to do titration. Wow. Titration. We need to do titration. So if you talk about titration, you are interfering or interventing the progress of a reaction. Okay, how? You are for example, this equation. So you may find is then organic substances colorless, and colorless. No gas formation, isn't it? Right? You cannot measure pressure change. You cannot measure volume of gas change. You cannot measure the color change, right? You cannot measure how cloudiness it will be, because most of the time it's still colorless. So what can we do to keep track of the reaction? So we will use this, sadly, forced to be. I must tell, forced to be. I try to measure the change in concentration of an alkaline by titrating against exit of known concentration. Can you get my point? It is the only method, but you may find that I tend not to use this method because it's too troublesome. It's too time consuming. It's too complicated, isn't it? But whatever you can choose, just choose the easiest method, isn't it? Most convenient method. But sadly, for that type of an equation like this, sorry, no, we are forced to use this complicated method. Can you get my point? We are forced to do so. So, but the question comes. I would like to show you this part before we come back. So the reaction will be, the design experience should be this. Once I mix the chemical here, okay, once mix the chemical, I start the timer. While the reaction goes, how do I keep track of the reaction? At certain time interval, for example, 1 minute. Every 1 minute, for example, I would extract a small volume of solution from here and try to deliver to another container in which it is an ice cold water. What is the purpose? I will rapidly stop the reaction. We call it quench, Quench, quench. Rapidly stop the reaction. Stop it. Let that reaction mixture here continue. But I only stop this part. Can you get my point? Now, you know that doing titration will take you so many minutes, right? You better stop it. How? First of all, why? Do you understand why do we use ice cold water? You can stop the reaction. How? What is the principle behind? Do you understand? Do you understand how come I pour the solution mixture to the ice water would we stop the reaction? How? What's the principle? Do you understand? Do you know the reason? Where are you here? Yep.
Yes, I'm here.
Tell me. Why would pouring the solution mixture of ice cold water mixture would we slow down or even stop the reaction?
The kinetic energy decreases, so the particles will not collide.
Wow. KE. Physics student, isn't it? Are you physics student, right? Temperature degree, the KE, kinetic energy, how fast the movement, the particle, they will slow down, right? If you don't understand physics, you will say that, right? Temperature decrease, the molecule move slower, more slowly. Can you get my point? So they will say that the particle will move slowly, so they will decrease the chance of collision. So the reaction rate will drop. Can you get my point? Now, of course, that type of concept, you'll know it in later chapters. Now take a look on this. Now you are going to cool the temperature, cool the sample ice rapidly. You dilute the sample with a large volume ice cold water to lower the temperature and the concentration of reactants. I will choose this method. Why? Because not only I decrease the concentration, I know the rate will decrease, but also I decrease the temperature would also decrease the rate. Can you get my point? If I'm going to make a concerted effort to make both happen, okay? So if you want to get to know how much slower it can be, there is something quantitative. For example, concentration of solution decreased by half, the rate will be decreased by half. While the temperature dropped by 10 degrees, the rate will be slowed by half. Can you get my point? So in case I do it both, you may know that the reaction mixture inside will proceed the reaction more slowly than expected. So I use this concept for help. So can you get my point? We call that the concept, we call it quenching. Quenching. It's for you, it's for your convenience. Can you get my point? Without doing so, what will happen? It depends on how fast you are going to do titration. Okay? While you wait until you really determine the concentration of the alkaline remaining here, right? The reaction mixture still react. Can you get my point? So the longer the time you start the reaction, of course, the data will be more inaccurate. So that's why I better freeze it. You freeze the moment. You freeze the moment before you have enough time to do the titration. Can you get my point? Of course, the purpose is to determine the concentration of NaOH left over. So that's why on top, I use exit standard, which means known concentration. I'll use it as a known concentration for help. Of course, in order to do such, I will use indicator for help. Complicated enough? Yeah, very complicated, very clumsy, very time-consuming, troublesome, I must tell. Whatever, what language you are going to use, right? Don't say for language here. But for this type, we call it titrimetric analysis. We call it a chemical method instead, but not physical method. Why? Because you are going to intervene the progress of reaction. You are going to stop the reaction from going before you really measure. Okay, so of course that type of reaction they will run rather slowly. For example, it takes over an hour, it's over 30 minutes. We'll use this method. Just wait, okay? Can you get my point? For the big batch of the solution, it will take for 1 hour. But for you, you may wait. For example, every 1 minute, I take the solution and quench it, or every 3 minutes. It depends on how fast you can do the titration. And later on, once the solution has been quenched, you do the titration to determine the concentration of NaOH left over. So what will you expect to be the data? Now, the rate curve will be showing something like this. The concentration of NaOH versus time, you may have got this data. Right? That data, if you're going to draw it, you project it as a curve, right? That curve, it is similar to what you know it in the previous example, right? But this time, the keeping track is made by titration. It's made by chemical method. Very terrible, isn't it, right? Any questions so far for that? Do you understand? Now, take a look on class practice. We try to mark the end of today's lesson. 2 more minutes to go. First of all, tell me, why is it better to select a method which avoids sampling for the following progress of a reaction? Avoid sampling. Leung Guan Yu, why do you think that you better not to choose this method? If you can really choose.
It is too clumsy, maybe. I don't know.
Sorry. Can you speak louder? Sorry. Could you please speak
hello,
up?
hello. Can you
Hi.
hear me? Hello.
Yes, speak louder, please. Thank you.
Okay. Let me see.
I will avoid choosing this method.
What's avoid choosing this?
Yes.
Is take too long time. Maybe.
Yes, you take the samples. It's rather troublesome. The procedure is more complicated than what you are going to, for example, measure the change in volume of a gas, measure the change in pH. It's easy, right? You just have the instrument and keep track, and that's it. Just sit here and wait. But for this part, sorry, you need to do quite a lot of process. It takes time. Okay, it takes time. Besides, that is point number one. Okay, point number one. This is a very slow process. It takes time. And second, we have got another reason. Is that while you take the samples of the solution mixture, you may have a risk of contaminating the solution mixture. Contaminating, which means we make the solution dirty. Do you understand? It will make the solution dirty, and which means you are disrupting. You have a possible case of disrupting the whole progress of a reaction. So that's why, if you can really choose, okay, you better avoid doing sampling. Can you get my point? How about question 2? For the reaction between propanol and iodine, they will react according to the equation below. Suggest how the reaction could be quenched. How? A part. Just have a recap of today's lesson. How would you quench the reaction? Quench. How will you quench the reaction? What's the meaning by quench? Quench, which means rapidly stop the reaction. How will you rapidly stop the reaction from carrying out? Anyone who know? You may turn on the mic. For those who read, you know how. Let me know now. No idea. Quench. How will you freeze the reaction? Same principle.
The solution in ice bath.
Ice bath, yeah, that's right. It's not just put it in ice bath. Ice bath can, by doing so, you can rapidly cool it down. But if you want to rapidly stop, I do one more thing, dilute it. OK？ 即係你冰鎮就係溫度下降啊嘛，冰鎮就溫度下降，咁你個 reaction 咪慢咯。但係我就要做咩啊？又要冰鎮又要溝氣，個 reaction rate 會點啊？再慢啲啦，明唔明 ？Quenching 嘅意思就係咁噶。Quenching 嘅意思係 rapidly stop the reaction。咁當然啦，有同學話阿 Sir 真係 stop 到嘅咩？唔係，冇 stop 到㗎，係慢啲㗎咋。所以你都係要快手做㗎。頭先我講咗啦嘛，就係點樣 stop 法啦。嗱，假設啦，大部分情況都係嘅，嗰個solution 嘅濃度溝稀1倍，個 rate 就會點啊？就會溝稀1倍啦。OK？ 就會慢1倍嘅。How about the temperature? Temperature drop by 10 degrees, the rate will be slow 2 times. Will be slower than 2 times, right? So you add it together. By doing so, you can do a combined effect. It will make the solution mixture much slower. So we call that quenching. Can you get the point? Somebody may argue, Mr. Yu, would it affect the number of moles of the acid remaining. Now you may find the whole progress of reaction. You are going to have this acid here, right? So what you expect is to think of the solution being more acidic, right? Because the more hydrogen ion will be formed. If I rapidly cool it down or rapidly dilute it, it would affect the concentration, isn't it, right? Don't worry. The number of moles of hydrogen ion will not be changed. You still need to go back to the number of moles of hydrogen ion, right? So that is our first step. The first step is add the sample to the excess or large amount of ice cold water. This is our first step. Why? As said before, temperature decrease and concentration of solution decrease. The rate will become slow, much slower. This is our purpose. Do you understand? You understand? Second, and then you try to take a small sample to monitor, to supervise how much acid has been formed. So you may see the word take samples of small volume at regular time interval. What is mean by that? What is mean by at regular time intervals? For example, every 5 minutes, every 10 minutes, every 1 minute. It depends on you, which means that every certain minute. It depends on how much data you're going to collect. Somebody who want to really make a curve like, right? And somebody would not would be feel so comfortable, right? While dealing with so many titrations. If you really can manage, for example, every 1 minute， 每分鐘 take 一個 sample 咯，係嘛？好準啦，係嘛？你個 curve 咪越嚟似個 curve 咯，30秒咧，10秒好唔好啊？我話俾你聽，10秒我冇乜可能㗎啦，因為你抽取用 pipette 嘛，抽取 while you pipette the solution, it will and unavoidably takes you more than 10 seconds, right? So 1 minute is our common limit. Now, no need to mention you need 1 or 2 minutes for titration afterwards, okay? So you carefully choose what is the time interval to collect the sample. Number 3, quench the solution mixture by what? By what? What is the best method after hearing all those? Large amounts of cold distilled water. Do you understand why? I do combined effect of much to slow down the reaction. What's the combined effect? One is what? What factor? Temperature. The other one is concentration. Can you get my point? I lower the temperature, the reaction will become slower. I lower the concentration of solution, the reaction also slower. What if I do it both? Of course, the rate will be much slower. Do you understand? So the missing blank, you just copy that one above. Can you see the arrow? How about number 3? In case I stop the reaction, I stop the sample from the chemicals from reacting, continue reacting, you can do the titration. Because you are going to measure the acid form. Of course, this time use alkaline on top. Titrate the sample with a standardized NaOH. Do you understand? Which means that during titration, NaOH is above, in the burette, while the sample here, quench mixture, it is found here with acid here. Can you get my point? And do the titration. Of course, somebody may think that, I need to end the indicator. Yes, just tell me what is the indicator needed, right? And finally, you can determine the hydrogen ion concentration sample at different time. Do you understand? That please copy it down. Any questions so far? Now, after getting to know all different methods mentioned, which method would you choose, right? If you can choose, right? If you can choose, please choose the most convenient method. please choose the easiest method, right? But you may unavoidably try to compare them. Okay, you need to compare them. Now, so far, we talk about some physical method. We talk about chemical method. We talk about continuous method. We talk about discontinuous method. We talk about the method to just like CCTV, monitor the progress of a reaction. Now, we call that physical method. But for chemical method, no. Just like you are the director of taking the film, you let the drama go, and you suddenly call a stop, cut. Okay, so what am I going to do? I stop it and supervise what is happening, and then I ask you, please continue. Stop, please continue. Okay, get my point. So this is something like titrimetric analysis. You are intervening the progress of a reaction. But if you use CCTV to keep track of a reaction, just like this one, you are not going to, you just monitor the progress of reaction, but you are not intervening the progress of reaction. Can you get my point? Do you get to know the difference between the two? Did you get the difference? Do you understand? So that marks, it seems like, what is meant by the physical method, CCTV, chemical method, just like a director asks you to cut while you do the drama. Understood? Understood? So next lesson, we try to compare all those different methods, first of all. Second, under what situation you'll be given the equation, you are going to be asked to choose the suitable method. Now, after getting to know all those different methods, the details of it, the principle of that, it's time to choose. Okay? Can you get what I mean? Now, tell me your level of understanding and tell me what is the difficult part to you today. Now, I would like to double check your attendance now. Please wait for me for a while. It's just Dan Hei and Choi Hei we just absent, right? Now, can I have the level of understanding today from 0 to 10? Just type it in the chat box. Do you understand?寫翻低0到10。但我用好簡單用中文講一次，就係我哋今日講多咗2個方法嘅，係咪？呢2個方法咧就得意嘅，有幾咁特別咧？就第一個方法咧就係有個 Mark Cross 實驗啊嘛。咁呢個特色係咩咧？我係冇去跟進晒成個 reaction 完嘅，即係好似跑25圈咁樣。之前咧就真係要你跑足25圈，我由頭到尾睇到尾，係咪？咁我就出現咗個 rate curve 啦，係咪？開頭快，跟住越嚟越慢，最後就好似唔喐咁啦，係咪？咪同你跑緊25圈一樣啦，係咪？咁但係咧，我哋交叉實驗就唔係嘅，我就同你講你跑25圈，不過咧我就去到第5圈咧我就停一停嘅，我就 check 你第5圈你要繼續跑㗎，去到第5圈嗰一刻我就計你頭5圈嘅速度嘅時間嘅啫，就完㗎啦。唔同人都好，你都係跑25圈，不過我就係睇第5個圈，你嗰陣時你用嘅時間就完啦。咁我點樣比較你同佢跑25圈嘅開始嘅速度啊？你會點樣比較啊？咪就係睇頭5圈咯，係嘛？梁君如跑頭5個圈要用10分鐘，係嘛？梁榮俊跑頭5個圈用7分鐘，咁我驚話梁榮俊跑得快啲啦。點解啊 ？rate 係同 time 係成反比啊嘛。用嘅時間就越短，你咪話速度越快咯。咁呢個咪反比咯，明唔明？頭先我就講呢樣嘢啫，明唔明 ？get 啦？好啦，第2樣嘢啦。我哋有一個逼得不已嘅方法嘅，就係呢個啊嘛。呢一個係咩咧？呢個最乞人憎嘅就係，如果又度唔到氣體生成有幾多，又度唔到氣壓着改變幾多，又度唔到顏色改變，又度唔到個質量改變，咁點算啊？又睇唔到個 solution 越濁，譬如呢啲咁樣，好似乜嘢都冇發生過咁樣，冇色加冇色就變冇色加冇色咁樣，我點樣度啊？譬如呢啲咁樣，咁我用 titration 啦。咁你用咩 titration， 用咩方法咧？你要睇下嗰個 reaction， 究竟我想 keep track of 邊個嘅份量嘅改變。 嗱，有陣時喺左邊，有陣時係右邊嘅，通常就酸鹼啊嘛，係咪？你講titration一定講酸鹼，你冇揾翻邊個酸邊個鹼咯。譬如呢個 case 嚟講，個鹼喺左手邊，咩意思啊？就話隨住 reaction 嘅進展，嗰、個嘅鹼咧個濃度應該會越嚟越跌，係嘛？酸嘅話會點啊？就會越嚟越升啦，係嘛？明唔明白？得唔得？得唔得？明唔明白 ？OK， 咁我就係做呢樣嘢咯。咁所以但係個問題係，我抽完樣做完抽樣檢查嗰個 solution 啊，佢入邊嗰抽少量 solution 嗰陣時，個 reaction 仲喐緊噶嘛，係嘛？仲行緊噶嘛，所以我咪快啲冷卻佢咯，冷卻佢咪 reaction 慢啲咯。咁我話叫 quenching 啦，最後做 titration， 明唔明白？咁所以咧，我要干預個實驗嘅，有冇嘢問？嗱冇咧，唔好意思啊，因為我呢度個間房佢要開會啊，所以我都要離開呢間房，得唔得？有冇嘢問啊？嗱冇嘅話，你要有嘅話咧，喺個 WhatsApp 度問，好冇 ？OK，
OK，
咁多啦，再見啦，拜拜。
好，拜拜。